Hey everyone, it's Mr. Lambert with today's lessons and notes for Monday, February 1st, 2021. We are moving on into Chapter 7 of our textbook, and we are going to be focusing on the skill 6.af.2, which is using common properties of mathematics to create and solve algebraic equations and expressions. So, first thing there, we need to get some vocab down. Now, these should be kind of reviewed because you should have already added a couple of these terms to your notes for today in your vocabulary section, and we actually looked at some of these last week as well. So, big thing here. An equation is a mathematical sentence showing that two expressions are equal. This contains an equal sign. So an equation is going to contain an equal sign. So the question the book wants us to ask is, what's the difference? What's the difference between an equation and an expression? So again, our equation definition is right up above. So an equation, it's a math sentence showing that two expressions are equal. So if we wanted to do that, let's see, let's get my pen here. I just need something containing an equal sign and two expressions. So I could say 3 plus 3 equals 6. This is an equation because 3 plus 3 and 6 are an expression. I can even add a variable in there. So 3 plus 3x equals 6. In this case, I know x equals 1 because I didn't change anything over here, but that's beside the point. This is still an equation because I have an expression, an equal sign, and another expression. Even a number by itself can be an expression. It's just not an algebraic one. Over here, an expression, well, this is the same thing. It's still showing a real-world situation using mathematical terms, but I don't have an equal sign. I'm not showing that two expressions are equal, so this is an expression, not an equation. And there's the difference. How are they similar? Well, they both show situations from the real world using mathematical language, using numbers, operators, and sometimes variables. But they're different because an equation is showing how two expressions are equal. The expression is just one side of that equation. So there you go. I hope that makes that gives you a little better understanding of the difference when we use these two terms of equation and expression. So today we are going to move on into, we've been working with expressions for quite a while, just the one side of a problem. Today we're really going to get into working with equations using algebra. So here's an example. Anna bought a package of 6 pairs of socks. She writes the equation below to find out how much she pays per sock, or per pair of socks. And they want you to circle the solution to this equation. Well, I'm going to circle for you, but I would like you to pause the video here. You've got 3 different answers there. I want you to use whatever method you want to do to try to figure out the answer to this equation. Now, I do want you to pause it and try to figure it out. Don't just wait for me to tell you the answer because that doesn't really help you with much of anything. There's no grade for me telling you the answer. So go ahead and try it out, and we'll check it here in a second. Okay, hope you paused the video. Here we go. Well, there are a number of different ways I can do this. I can plug these numbers in. I can do 6 times 50 cents, or 0.50. I could multiply that by 6 and get an answer. If that didn't work, I could move on to my next one and then move on to the next. That's one option you could use. I could also use things that I know. Like, for example, I know that 6 times $1 would give me $6. So using half a dollar would not be a way that I could get back to my $9. I would have to have more than that. So I know it would have to be at least $1.50 or $2. And I know off the top of my head 6 times 2 is 12, which is too much. So I would know that I would fall on $1.50. So there are just 2 options that you could use to figure it out. You could use repeated addition and see what added together 6 times gives you 9. Any way that it works for you. The whole thing here is there are lots of different ways to get to the answer of an algebra problem. In this case, we're using guess and check, or we're using what we already know. We're reasoning abstractly, like what I did just right there. Well, I reasoned abstractly. from two things that I knew that wouldn't be correct, I constructed an argument that this would be the correct one. I could model it with math by multiplying these two to check my answer. That would be attending to precision and using my math tools. You can make use of structure, things you know about the problem that make you know things are true or not true. There are a lot of different ways you can go about solving a problem, as long as you get to the correct answer, I suppose. All right, so let's move on. Here are a couple to check out. See if you can do these. I would like you to pause the video and try these 3 problems out. I'll work through them really quickly. This will kind of be your guided practice for today. So please go ahead, pause this video, grab a piece of paper out, see if you can do some of these mentally, like letter B they want you to just do by thinking in your head. Just jot down your answer, and we'll check them together here in a second. Okay, so here we go. I've got 4, 5, and 6. It says, which one of these is the solution to the equation C plus 8 gives me 13? Well, I can just start plugging in and see what works and what doesn't. I can also do, well, I'm a reasoning abstractly kind of guy. I know that an even number plus 8, which is an even number, should give me an even number. That means my answer has to be odd. It can't be 4 or 6. I know it has to be 5. I also know, just from knowing my math facts, that 5 plus 8 does give me 13. I could also do something like, I know 5 plus 5 gives me 3, that would be 10, and then 3 more on one side would give me 8. So 5 plus 8 gives me 13. Again, a lot of different ways you can figure these out. 9 minus x equals 2. Well, again, I can guess and check, or I can use what I know. So 9 minus 9 would give me 0. In this case, I would count, I don't want to get 0, I want to get 2, so that means I need to take 2 less away. And 2 less than 9 would be 7. So in this case, I know that 9 minus 7 equals 2. I can also just start plugging single-digit numbers in there and get to the right answer. It doesn't matter what method you use as long as you get there. Last but not least, the difference between an ostrich's speed and a chicken's speed is 31 miles per hour. An ostrich can run at a speed of 40 miles per hour. So use mental math or the guess, check, and revise strategy to solve the equation C minus, or 40 minus something, which we'll call C, equals 31, to find C, which is the speed that the chicken can run. So how fast can this chicken run? Well, in this case, I use what I know. If I took 10 away from 40, I would get 30. This is 31, so I need to subtract 1 less. So this would be 9, because 10 minus 9, or 10 minus 1 is 9. There are a lot of different ways you could do it. I could take 31 and I could count up and see what I come up with. So 32, 33, 34, 35, 36, 37, 38, 39. Well, there we go. Oh, 40, sorry. We got to get 40, and there's 9. That's how I would do it with my daughter. She likes counting up when she does subtraction. There are a lot of different methods you can use to find that answer. You've just got to use one that works for you. When you've got an answer, go ahead and check it, plug it into the equation, and see if it actually makes sense. All right. So we are going to focus on working on things mentally. If you need help when dealing with addition or multiplication, I will let you know that on my homepage, at least, there is a section called Anchor Charts. So if you go to Math, go to the homepage for Math. So when you're in Math, the Math course, go to homepage at the top. When you click on Home, it will take you to a page, and at the bottom, there's one of the blocks says Anchor Charts. If you click on that, there's a hundreds chart, and there's also a multiplication table, which should help you out with these as you're working through. All right, here's an example. Is 3, 4, or 5 the solution to the equation 18 equals 6z? Now, you'll have ones just like this today. In this case, well, we just have to guess and check numbers. So 3, well, I know that 6 times 3 does give me 18. I know that's going to be my missing thing. I know that off the top of my head because I know multiplication facts. And I know that 6 times 4 gives me 24. 24 and 18 aren't equal. I know that 6 times 5 gives me 30, and 30 is also not equal to 18. So 3 would be the solution to this problem. Again, you can use repeated addition. You can use those charts, whatever you need to do to get to that answer. You just got to get there. All right. Here's one more we'll do together, and then I'm going to have you solve these two on your own. So solve mentally. 16 divided by s equals 8. I want you to solve it mentally. Well, you could think 16 divided by what number equals 8? And if you know your division facts, you know that 16 divided by 2 equals 8. Or You might also know that 8 times 2 gives you 16. In either case, you would know that 2 is the number that needs to be plugged in for S. So S equals 2, or the solution is 2. All right, try that out with these next two problems and see what you come up with. So pause the video, try these problems. We'll check them here in just a second. Okay, for letter D. 2, 3, or 4. What is the solution to the equation of 4 times n equals 16? We're trying to solve for n. Should it be a 2, a 3, or a 4? Again, we can plug numbers in and guess and check. 4 times 2, I know is 8, so that does not equal 16. 3 times 4 is 12, which won't give me 16, that will give me 12. Or 4 times 4, that doesn't give me 16. I know that n equals 4. My solution is 4. For the second one, 24 divided by w equals 8. Again, if I'm doing that mentally, I use the inverse operation, or I think of the opposite. So what can I multiply 8 by to get 24? It's kind of the opposite of division. In that case, I can look at a multiplication chart and know that that is 3. Or I know that 24 divided by 3 equals 8 if I know my division facts really well. You could also, again, add it up over and over again, use repeated addition to figure out how many times I could use 8 to get to 24, and you would also come up with the answer 3. All the same answer, 3 different ways of looking at the problem. So, all that to say, as you are working through your problems today, don't get hung up on trying to figure these out one way. Use whatever you know. If you need to use the anchor charts, that's cool. Use those to figure out what numbers could fit into that slot. If you know your multiplication, division, addition, and subtraction facts really well, this should be a breeze for you because you're just plugging in that number that is missing from the equation. All right, that's what you're going to be working on in your independent practice today. If you have questions while you're working, make sure to give your teacher a call, and we will for sure help you out. Good luck today, and we'll talk to you again soon.